All right, we're switching things up to look at the three-dimensional coordinate system. We are in lesson 10.1, and I'm on page 712 if you want to take a look. So it says, how do you locate points, find distances, and graph equations in 3 dimensions? So we're going to start with the good old distance formula. The distance formula is very similar to a regular linear distance formula, but now we have the distance is equal to the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared plus z sub 2 minus z sub 1 squared. The other popular formula in Algebra 1 is this midpoint formula. Remember, the midpoint formula is just the averages, x sub 1 plus x sub 2 divided by 2, y sub 1 plus y sub 2 divided by 2, z sub 1 plus z sub 2 divided by 2. Now, the first question is asking us to plot these in space. Do you like that word, in space? So we have to learn. The first thing that we have to do is draw our x, y, and z. So it's going to look a little different this time. This is actually our z. The z shoots straight up. Sometimes they draw the y sideways. I'm going to draw it kind of shooting out a little bit to give it a little bit more dimension. And the x is shooting over to the left. So if I had to go -1 on the x, I would go backwards this way on the x. If I had to go +3 on the y, that would go to the right, and +4 on the z. So I know this point, they kind of draw it like this. We know this is going to go out, this is going to go out, and it goes up 4. It's kind of hard to see. That point would be right here. And they would call this A. Let's see how we do with 2, 5, and 0. So 2 is going this way. 5 is going this way. And if I went over 2 and over 5, that would meet kind of in the middle this way. So this would be B. Well, I'm having fun, so I'm going to do one more. What about 1, 3, and 6? Let's go ahead and graph this one in dark purple. If I go 1, that's going to be here. That goes this way. 3, 1, 2, 3, 1, 2, 3. And 6, 1, 2, 3, 4, 5, 6, that's going to go all the way up to here. And that I'm going to call C. How are we doing? Do you like these 3 dimensionals? Pretty cool. All right, our example 2 leads us to the distance. So remember, the distance formula is going to equal x sub 2, which is 2, minus x sub 1, which is -1, quantity squared, plus y sub 2 minus y sub 1, plus z sub 2, that was a -6, minus z sub 1. And we're going to square all of that and put it underneath a radical. So I know that this is 3 squared, 9. 9 squared, 81. And 7 squared, -7 squared, which is 49, which is going to give me the square root of 139. Distance formula. Very similar to what we do with linears. All right, the midpoint formula, remember we're just going to take the x's, divide by 2, y's, divide by 2, z's, divide by 2. So let's do that. 2 and 1 is 3/2. -2 and 3 divided by 2 is 1/2. And 4 and 6 is 10 divided by 2 is 5. So the midpoint would be at 3/2, 1/2, and 5.